measurement, and really this lesson should be called measurement in 3D space. Because that's what we're going to do. Right, we're going to apply all those rules for volume, surface area, and then now do it for objects in 3D space. So let's do a couple of examples. A square base pyramid has base coordinates of 0, 0, given, basically. 0, 0, 0, 4, 0, 0, 4, 4, 0, 0, 4, 0, and the apex of the pyramid is 2, 2, 5. That's this part right here. Verify the apex lies directly above the center of the base. So we want to find the center of this base here. So all we're going to do is find the midpoint of like all the corners, and that should give us the center. So for A, we're going to find the midpoint of this guy, right? It should be like right there. And then we're going to find the midpoint of this guy. It should give us right there. We're just trying to show this is directly beneath this. So actually, the 5 thing we don't care about. Like that's if we're beneath it, that's not going to be. It's going to be a 0. So we just want to try to get the 2, 2 here. So again, we're just going to find the midpoint of these two. Let's find the midpoint of AC. So remember, all you do there is add up the x values and the y values and divide by 2. Oh, in this case, x, y, and z values divided by 2. So we're going to add 4 with 0 divided by 2. 0 with 4 and divided by 2, and then 0 with 0 and divided by 2. And I get 4 over 2, 4 over 2, and 0 over 2, so I get the 0.220. So that's the midpoint there. I should confirm that's also the midpoint of this one here. But if I add, so I'm going to do the same thing with OB. Anytime you see O in IB, that generally means the origin. So it's going to be for us here. That origin, we'll call it O. So it's going to be 0 plus 4, because origin is 0, 0, 0, divided by 2. 0 plus 4 divided by 2, and then 0 plus 0 divided by 2. Right, I'm getting the 4, 4, 0 from this point. This is my x2, y2, o2. So that's where the 4, 4, 0 came from. 0, 0, 0 came from the origin. This is 0, 0, 0. Anyway, and I get 2, 2, 0. So that is my midpoint, and that is directly below, I should say, my apex. Find the volume of the pyramid. So volume of the pyramid is 1/3 area of the base times height. Now there's some good things we can do since we actually know that we're in 3D space. Like, we can actually figure out how long this is. Right, we went from 404, like this point right here is 400. On our y, how much did we move to get to 440? We moved 4 spaces on our y. So we went from 0 to 4 on our y. So this is the length of 4. And then it is a square base pyramid, so I know this is the length of 4 also. The height? Well, this ground here is 0. You can tell by all the zeros on my z's here. And what's the height here? 5. So my height is 5. So I have everything I need for B. To find the volume, it's going to be 1/3 area of the base, which is 4 times 4, because it's a square, times 5. So I'm going to get 20 times 5, which is 100, so 100 over 3. What is it? No units? Okay, no units. So that's B. C, suppose M is the midpoint of BC. Okay. Find the coordinates of M. Well, if we want to find the coordinates of that, remember all you have to do to find the midpoint is add them up and divide by 2. So I'm going to add 4 plus, let's do it here, I guess. My midpoint is going to be 4 plus 0 divided by 2. And then 4 plus 4 divided by 2 for the y value. And then 0 plus 0 divided by 2. And I get 4 over 2, 8 over 2, and 0 over 2. So I'm going to get the point 2, 4, and 0. So that's midpoint, 2, 4, 0. Find the exact length of MD. So M to D right here. So we want to find that length. Now there's a couple ways to do it. We could do a right triangle because I know what the height is and I know what this is. So I could do this like we did back in that chapter. Right? I know this is 5. I know this is 2. So I could do a squared plus b squared equals c squared and get radical 29. That's one way. Another way is I could use the distance formula on these 2 points. And I think that's the way they want us to do it. So I'm going to do this down here. C2. This is the distance formula for dm. D is 225. And m is 240. So if I did the distance formula, it's going to be x2, let's call this one, minus x1 squared plus y2 minus y1 squared plus 0 minus 5 squared, z1 minus z2 squared. And I get, well, that's a 0 squared, and this is 2 squared, that's 25 squared. Oh, sorry, 5 squared. So I get 4 plus 25, which is radical 29. So I get the same answer either way. Hence, find the surface area of a pyramid. I'm running kind of running out of space here, but surface area of a pyramid is area of the base plus perimeter of the base times the slant height. So we just figured out what the slant height was, rad 29. I know what the area of the base is. We did it earlier, 4 times 4. Perimeter of the base, it's just add up all the sides. So 4 plus 4 plus 4 plus 4, so 16. And then times that by the slant height, which is radical 29. So I get 16 plus 16 rad 29. Very messy, I know. Sorry about that, it's kind of run out of space. But that's the idea. So let's do one more. The point 4, negative 610 lies on the surface of the sphere with center 231. Find the radius of the sphere. So I don't have to draw anything out, but so they tell me, well, I could probably draw this a normal picture so you could see. Right, so they're saying it goes like this, and this spot here is negative 4, negative 6, and 10, and my center is 2, 3, negative 1. Now, if you notice, I didn't draw a 3D space because it doesn't matter. It's the idea of what's going on here. So here's my sphere, there's my center, there's my endpoint. Find the radius. Well, that's just the length of this guy. So we're going to do the distance formula again. So remember, we'll just say x1, x2, y2, I should say, is z2. I really messed that up. I'm going to say x1, y1, z1, and then x2, y2 is z2. There we go. I don't know what I was thinking. So this is from right, so it's going to be square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So I get negative 6 squared, negative 9 squared, and 11 squared. That's going to be big. 36 plus 81 plus 121. Remember when you square all out, when you square things, it becomes positive. I'm going to use a calculator to do this. So let's see, 36. So I imagine it might actually work out nicely. Plus 81 plus 121. There we go. So nope, did not work out nicely. Let's take the square root of that. Well, for now, let's put the distance as square root of 238. And the next one says, find the volume of the sphere. Well, volume of the sphere is 4/3 pi r cubed. So I'm just going to leave it like this and plug that in. 4/3 times pi times radical 238 cubed. And again, I'm saying about that. That's my answer. You don't need to simplify unless they actually ask you to put in your calculator. Then you just put in your calculator. But that's the idea, right? So using the same idea, but now you're in 3D space and use that, and that has some advantages, some disadvantages. Like doing distance kind of sucks, but it does make some things easier to find. And that's the lesson.